Today's notes are over function notation. We're going to start out by defining a function. It is also a function is a rule that has input values and output values. Our input values are also known as the domain, which we also know as our x values. Then the domain, our output values are also known as the range, which we also know is y. So again, a function is a rule that has input values or x values and output values. So our first example, we have a visual representation where we have our function is the machine in the middle with our rule being 2x plus 3. We are going to plug in our domain, our x values, into our rule for x right here to find the output value or the range. So here is our first example. I have x here and x here. I'm going to plug in our first x, which is -1. Like so. So f of -1 equals 2 times -1 plus 3. 2 times -1 is -2 plus 3 is 1. So we read this as the function f when x is -1 gives us 1. So this is our x and this is our y. We can also write this notation, this function notation, as an ordered pair, x comma y, where this is x right here, and then our y is our output, which we put right here. So it's also the same thing as -1 comma 1. Our next x value that we're going to input is 0. So f of 0 equals 2 times 0 plus 3. 2 times 0 is 0, plus 3 gives me 3. So the function f when x is 0 gives me 3. So our 0 is our x value that goes here, and our y value is the 3 that we found, which goes here. So the ordered pair 0, 3 is the same thing as this notation up here, right here. All right, and then the last one, our last x value is 1. So f of 1 equals 2 times 1 plus 3. 2 times 1 is 2, plus 3 gives me 5. So the function f when x is 1 gives me 5. So 1 is our x, and then 5 that we found is our y value. Okay, so up here in the machine visual, we plugged in -1, 0, and 1 into our rule, a 2x plus 3, and we got some values for y. So we put those in our set. The set of the range was the green that we found below. 1, 3, and 5. We can also transfer these y values to our table. When x was -1, we got 1. When x was 0, we got 3. When x was 1, we got 5. So our y values are on our right, and our x values are on our left, like we discussed last class. Okay, so here's another example. Our rule given is the function f of x is x squared minus 3. They give us, again, the domain, which I had in blue. Okay, so they gave us this side, and we're looking for the range, the y values. So on my table, I have -2, 0, 2, and 4. Instead of doing all the math and plugging each one of these x values to find each y value, we can use some technology to save us time. So let me connect real quick. 1 second. So take out your calculator. Okay, so cancel this. We are going to go to y equals, and if you have anything on these, you can just clear them. I'm going to put our function rule, which we said was x squared minus 3. So we put x squared minus 3. And then we're going to hit this blue button the second, and then the graph button to get the table. So right here we have listed all of our x values. So looking at the x values that we were given -2, 0, 2, and 4. So we're going to look at the left side of our calculator for these values. We can just use the arrow buttons to go up and down. So when x was -2, we got 1. When x is 0, we get -3. When x is 2, we get 1. And when x is 4, we get 13. So those are the y values that we are going to write down. So again, when x was -2, we got 1. When x was 0, we got -3. When x was 2, we got 1. And when x was 4, we got 13. So these values in green that we found from our table, we'll put in our set for the range: 1, -3, and 13. And remember, we don't write the numbers that we repeat when we write our domain and range. So I only put the 1 time. These x and y values can be written as ordered pairs, x comma y. So our x values are always going to be the first one we write, and our y values will be the second number that we write. So looking at our table, when x is -2, we get 1, then 0, -3, 2, 1, and 4, and 13. All right, here's the next one. This time, it says find the domain. So we're looking for the x values this time, and they give us the range, the y values. Our rule, or our function this time, is -2x minus 4. So again, using our calculator, we are going to put in the function. So we go to y equals, we can clear this one, and we're going to put -2x minus 4. Then hit second graph. But remember, this time we're looking at the y values because those were the ones given. So using our arrows, we'll go up and down. When y is -16, x was 6. When y is -8, x is 2. When y is -2, x is -1. And when x is 4, when y is 4, our x is -4. So over here, we'll put in the x values that we found, which were 6. Let me go back to black. So it was 6, 2, -1, and -4 were the y values. So in our table, we'll put our x values on the left, our y values on the right. So the x values we found were 6, 2, -1, and -4. Our y values were -16, -8, -2, and 4. And remember, it's important that we put, when we do our table, the x value has to go with this y value. So when we checked on the calculator for -16, we had 6 was the x, and so on for the rest. Okay, and what is given to us this time, I talked about in the beginning. What was given was the range. So I should have wrote that down first. We were given the range, and we found the domain. Okay, and then for our last example, same thing, but this time we're giving a list of ordered pairs. So taking our highlighter, we're going to highlight all of our x values, -2, 2, 4, 6, and 8. Then I'll highlight my y values, 6, 8, 10, 12, and 14. So this is function notation. This h of 6 is how we read it properly. But the way I want you guys to think of it is the function is h. Okay, they didn't give us what the rule is, they just gave us the name. So the function h when x is 6. So x is always going to be the number inside the parentheses after the letter. So we're going to find where x was 6 and find that y value that corresponds with 6. So x is 6 is right here, so my y is 12. Okay, so then for the next one, we have the function h when x is 8. So we go to when x is 8, it's right here. The y is 14. Right here. Moving on. We have the function h when x is -2. What's the y value? This is what we're looking for. So when h is -2, we get 6 as our y value. And then the last one, the function h when x is 6, what y value do we get? So we go to h is 6, which we already did this one. The first one we did on A. It's 12 again. And that's it for today's notes.